Welcome to this segment of my mathematics videos as we start the topic calculus, but we are focusing on what we are calling as being differentiation. So finding the derivative or the gradient of a given function. Now, what are some few concepts that you need to remember when it comes to differentiation or finding the gradient at a particular point? Well, you need to remember that we can apply the first principle, but in this case, we are not going to be using the first principle. We are just going to be using the rule. So you can apply what we are simply calling as being the first principle in order for you to find the derivative or the gradient, as we may call it. Or we can just apply what we are calling as being the rule, and that is what we are going to use. Now, in general, we can simply say that if you have a function y is equal to a then x raised to the power n. If you have a function a x raised to the power n, then it simply means that the derivative or the gradient of such a function we mean dy over dx. Now, why are we saying dy over dx? This is because outside you have the variable y, then inside the variable that is changing is x. So y is changing with respect to x. No wonder you are saying dy over dx. Suppose you had something that had maybe w is equal to 2t squared and the like. If you notice, this is w changing with t. So you are going to say dw over dt because the function w is changing with respect to t. So it's not always dy over dx. It depends with the letter outside and the letter inside that keeps on changing. So in our case, because I'm using y and the variable that is changing in the function is x, so that is why we write dy over dx. So what do we do? Well, you get the index, you multiply by the coefficient. So it is going to be an, then that will be x. So the index reduces by 1 when you are differentiating. So that is the rule that we are going to be using. Then another concept that you need to remember, if you have the function y is equal to k, where we mean that k is simply a constant, any number that you have. So for any constant, the derivative dy over dx is always a 0. So you need to remember that for any constant, if you are to find dy over dx, it is always going to give you a 0. So that is what you need to remember. For example, let me show you if you have a few derivatives there. Let's find the derivatives of the following. So we can maybe say find the derivative of the following. So find the derivative of the following. Let's say quickly we have maybe y is equal to x squared. Then b, let me say y is equal to 2x squared. And c, let's say that y is equal to 4x to the power 3. So how do you find the derivative of these ones? Well, it's very simple. What you're going to do is very simple. So for the first one that we have there, since they have given us that y is equal to x raised to the power 2, so for me to find dy over dx, the derivative, you get the power and you multiply by the coefficient in front. So remember, for a single, if you are differentiating a single term, you just need to multiply the index and then reduce the power. So it is 2 times 1, which will still give us a 2. Then the index will reduce by 1. So that is going to give us, 2 minus 1. That's what we mean. So this is going to be 2x raised to the power 1. But remember, we do not usually write 1, so it is going to be 2x. That is what you're going to have. So that's the derivative. So remember, if you are differentiating a single term, multiply by the index, the coefficient multiplied by the index, and reduce that index by 1. So that is according to this rule that we looked at there. So that is what you need to remember. Well, let's look at the B part there and try to see how you can go about that. So the B part says that y is equal to 2x raised to the power 2. Remember, dy over dx will be equal to this times that. So that will give us a 4x. Then the power reduces by 1. But of course, we don't write that one, so it will just be, 4x. So that is the derivative that you are going to have. What about for the c part? What is the derivative? Well, for the c part, if I'm to find, since it says that y is equal to 4x raised to the power 3, then dy over dx will be equal to 3 times 4, which gives us a 12. Then remember, the index reduces by 1. So 3 minus 1 will give you a 2. So that is dy over dx. So that is what you need to remember. So as a key concept therefore, if you are dealing, let me just give you just a simple concept that you need to remember there. If you are dealing with what we are calling as being a single term, so I can simply say maybe, to differentiate a single term, you multiply by the index. What we mean you multiply by the index is the coefficient, the number in front, and then reduce the index by 1. So that's the key concept. So if you're dealing with a single term, multiply by the index, that's the coefficient, the number in front, and then reduce by the index. Remember, if you have the number in this case, if you have the number, for example, 2 raised to the power n, this number here is what we call as being the base, and that one there is what we call as being the index. Sometimes it is called the exponent. Yeah, sometimes we call it as being the power, so you need to remember that. Now let me just give you a few rules that you need to use, especially that we are going to be dealing with negative indices. So a few rules that you need to remember, because we are going to be dealing also with negative index. Remember, according to to some rules, let me say notes on indices that you need to remember. So what are some few notes on indices that you remember? Well, if you have got the first one has to talk about the rule of multiplication. If you remember your laws of indices, if you have got a raised to the power m multiplied by a raised to the power n. For example, if you're having the bases are the same and you're multiplying, what you do is simply you add the power. So m plus n, that's what you're going to do. E.g., if I'm having x to the power 3 multiplied by x raised to the power 2, what am I going to do? Well, because the bases are the same, you just get the base, then you add the power. So that will be 3 plus 2, which will give us x to the power 5. The second one that you need to remember is the law of division according to the laws of indices. If you're having a raised to the power m divided by a raised to the power n, this can also be written as a raised to the power m over a raised to the power n. So what you do, you simply get the base, then what do you do to the powers? Because you are dividing and the bases are the same, you just simply subtract the powers that you have. For example, if you have got x to the power 5 divided by x to the power 2, it simply means you can say x, you take, because the bases are the same, you take one base and you subtract the powers. So that would be x to the power 3. So that is the value that we are getting. What about if you have x divided by x? What does that mean? Remember, x divided by x, of course, we know that that is a 1. But of course, this is according to when we apply the laws of indices. Remember, there's a 1 here and there's a 1, so it is 1 minus 1. And of course, 1 minus 1, we know that that is equal to 0. And according to what we know, any number, if we know, of course, that any number raised to the power 0 is equal to what? Is equal to 1. No wonder that is simply giving us just a 1. Okay, so that is what you need to remember. Another concept we can deal with a negative index. Maybe you can be dealing with negative index. Suppose I have got x divided by x raised to the power 3. How would that be? Well, that is going to be, remember there's a 1 here which you don't write, so it will be x1 minus 3, because the bases are the same and you're dividing, you subtract. So that is going to give us x minus 2. Now, how can we write, this one? Well, we can say, but when I look at x minus 2, that is simply going to, x minus 2, that is simply going to, to become simply 1 over, x raised to the power, x raised to the power 2. That's what we mean. It's like we can say it's like you're having x to the power, x divided by x raised to the power 3, which will give you 1 over x raised to the power 2. That's what we mean. So the key concept when you find that is that, you need to remember that a negative index, means the reciprocal. So a negative index means the reciprocal. So if you have got x raised to a negative index there, then just know that this is going to be a reciprocal. So that negative is like becomes a 1 over x, you raise it to a positive index. So please, you need to remember this rule. You are going to be applying it, especially as we carry out our differentiation. So you need to remember such rules that we are going to apply. All right. Okay, let's put up some other concept. Let's try to put up some other concept that you people need to remember to help you in your exam. Suppose you're finding the derivative of a polynomial. So we can say derivative of a polynomial. So if you're finding the derivative of a polynomial, remember poly means many. For example, you have y is equal to maybe 3t raised to the power 2 minus 2t plus 1. Imagine that you're finding the derivative of that. Well, the derivative of a polynomial such as this one is the sum of separate derivatives of the terms. So we can simply say that the derivatives of a polynomial, is the sum of the separate. So we can say is the sum of the separate, derivatives of the terms. So each term that you have, that's what we mean. So what do I mean when I say for a polynomial it's the sum of the separate derivatives of the term? So, well, I mean if you have y is equal to 3t raised to the power 2 minus 2t plus 1, it simply means that you're going to say dy over, remember what letter do you have there that is changing? It's actually t, for example. So we can say dy over dt will be equal to what? So it will be, remember the index multiplies by the coefficient. 2 times 3, that's a 6, and the power reduces by 1, which is 2 minus 1, which is just the 1. So I'll just write a t there. Minus. Here there's a 1. So 1 multiplied by, you can't see the 1, but there's a 1 there. 1 multiplied by 2 give you a 2. Now when you look at this one, it will become 1 minus 1. And what is 1 minus 1? It is definitely a 0. Any number raised to the power 0 will give you a 1. That's what we mean. So it simply means that it's like this 2, here you multiply by 1 plus, because this, when you differentiate, will just give you a 1. And for a constant, remember we said it is 0. Therefore, it will be 6t minus this times that will give us a 2. You can ignore the 0. So that is if we can say dy over dt or whatever variable that we had. So that's what we mean. You work out separately each individual term, you differentiate. Then the sum of that is simply the derivative of a polynomial. Let's try to look at a few examples. Let's try just to look at a few examples that I have there quickly, so that you are able to, to practice. It says differentiate the following with respect to x. So a there, they have given us, it says y is equal to x raised to the power 8. How do I find dy over dx for this one? Remember, it's the index multiply the index by the coefficient. So 8 times the number in front there, which is 1, will give me 8. Then this one reduces by 1. So that is going to be 8 minus 1. So that will give you 8x raised to the power 7. That's what we mean there. B, it says y is equal to 6. Remember, for a constant, what is the derivative dy over dx for a constant? It is just 0. You don't even need to start wasting your time. It is just 0. What about when we are dealing with a c part there? Y is equal to 3x. Of course, dy over dx will be equal to, remember, it's like you have a 1 there. Let me use a different marker. It's like you have got a 1 there. So 1 times 3 will give you a 3. Then it is going to be x. What will happen to the power? It will reduce by 1. So it will be 3x. 1 minus 1 is a 0. Remember, any number raised to the power 0 is a 1. So 3 times 1 will give you what? Will give you a 3 there. So that is what we mean. So the derivative. So in simple terms, when you have a number and a variable, you just remain with a number. That is what we mean when you differentiate that. All right, let's create some space there. Let's try to create some space and do the d part. Remember, for such things like a polynomial, y is equal to 3x to the power 5 plus 7. What is dy over dx? Well, dy over dx will be equal to, if you notice this one there, you do it individually. So it will be 5 times 3, which is going to give us a 15. But remember, the index reduces by minus 1. That's what we mean. The derivative of a constant is just 0. So therefore, we are going to have 15x raised to the power 4. That's what we mean there. Because that would definitely give us a 0. So we can ignore just the 0 there. E, if you notice that expression, I think I was interested with that so that you can remember. If you look at that one, they have given us it's the same as y is equal to x to the power 3 minus 1 over 2, x raised to the power 2 minus 1 over x. Now, if you notice, we have got, an index 1 over, according to the rule, if you have got, remember we did say x minus raised to negative n can be written as a reciprocal 1 over x raised to the power n. So meaning if you have this, it is possible for you to go back in that direction. So I can rewrite this and simply say it is x to the power 3 minus 1 over 2x to the power 2. This 1 over x can be written as x minus 1. That's what I can do. Now once we do that, it's possible for us to find now the derivative dy over dx. So how is that going to be? Well, it is going to be 3 times 1 will give us 3. Remember, the power reduces by 1, so that will give me a 2. Here, how is it going to be? It is 1 over 2. Remember, 1 over 2, you are multiplying half times 2, then x2 minus 1. That's the way it is there. What about there? It is going to be x. Remember, there's a 1 in front there. So it is going to be more like 1 multiplied by this negative 1. But that x will be, since it's a minus 1 already, so you subtract minus 1 there. So how is that going to be? It will be 3x squared. So this and that will cancel. You're going to remain with minus 2 minus 1 will just give you 1. So don't write it. That would be 1 times 1 is simply a negative 1. Negative times negative will give you a positive. That would be x negative 1 minus 1. Same signs you add, that will give me a minus 2. Now remember, you can leave it right here, or you can simply change this one back and write it as again a reciprocal, which will give you 1 over x raised to the power 2. So that's what we mean. So that is basically how you can work around with that one. All right, it seems to be complicated, but I just wanted you to take slowly so that you're able to see, especially on the last two, the steps that you can take to find the derivative or the gradient dy over dx, as we are calling it. But of course, like I said, it depends with the letters they are using. What about, f there? Well, f there says that now for f, we have got the same as y is equal to 2x minus 3, but raised to the power 2. Well, you can expand first of all this one. That's why if you find such a one, but in my next video, I'll show you how you can quickly, find that. But you can expand this one. Remember, 2x minus 3 means 2x minus 3 multiply again by 2x minus 3. That's what it simply means. So 2x times 2x will give me 4x squared. 2x times negative 3 will give me negative 6x. Then we come to this side. Negative 3 times 2x will give me negative 6x. Negative 3 times negative 3 will give me a positive 9. You can add the like terms. So we are going to have 4x squared, negative 6x minus 6x, same signs you add. So that would be minus 12x, plus 9. All right, that's what we mean. So meaning when you expand that, it's the same as y is equal to 4x squared minus 12x plus 9. That's what we mean. So once you expand, you can now find the derivative dy over dx. So 2 times 4 will give me 8x. That one reduces by 1 minus. Remember, if you have got just a number and a constant, you just remain with a number. Why? Because there's a 1 here. 1 times 12 will give you 12. Then here it will be x 1 minus 1. Any number 1 minus 1 will give you, it is x to the power 0. Any number to the power 0 is a 1. So it's like 12 times 1, which will still give you 12. So if you have a letter and a number, please just remain with a number. Plus for a constant, it is 0. Therefore, we can reduce that. It will be 8x minus 12. So that is the derivative that we mean there. So basically, you'll be finding such expression. But in my next video, I'm going to show you how you can easily do that without even, wasting time expanding. So we'll come up with a simple way of trying to do that. Right? Our last question there, which is our G part there. Our G part there says y is equal to, so y is equal to 4 raised to the power 3, 4 over x to the power 3. Now remember, according to the rule that we used, if you have this number can be written as 4 over, this number 4 over x to the power 3 is the same as writing 4 multiplied by 1 over x raised to the power 3. I hope you agree with me. And if you notice this expression there, it's like you're having 1 over x raised to the power n. According to that rule I told you, this one can be dropped down and it will become a negative. Okay, so remember we said we can go in this direction, we can also go in that direction. So therefore, before you differentiate, drop that 4. It would be 4. When that 4 drops, it simply means that the index for this x to the power 3 will now become a negative 3. So when you drop that 4, this one will become, the index will become a negative. So now, once we drop it now, that's when you make it easy for you to find the derivative, dy over dx. So what is that going to give you? Well, it is negative 3 times 4 will give me negative 12. Then what did we say? The power reduces by 1, so it will be minus 1. So this is going to give us negative 12x. Negative 3 minus 1 will give me negative 4. Remember, again, I can drop, when I remove this negative, it will become negative 12 over. The moment I remove that negative, this x to the power 4 will drop down as a positive index. So that's what we mean. So that's our derivative dy over dx for such an expression. Please watch out for my videos so that you can get more concept on this one. Thank you.